I am Mr. True. In this video, we're going to do 3 examples of finding derivative of sine and cosine. We're going to worry about the other 4 trig functions in another video. So, for sine and cosine, the derivative with respect to x of the sine of x is equal to the cosine of x. And the derivative with respect to x of the cosine of x is equal to the negative of the sine of x. I don't want to do this for both of these statements, but for this second statement here, I've gone ahead and I've drawn one period of the cosine function, and I want to just talk about why is the derivative, or just show you, why is the derivative with respect to x of the cosine of x equal to the negative sine of x? Well, as you look at this, what you'll have to remember is, again, derivative will tell us the slope of a function, of the original function, at pretty much almost any value of x, unless of course the original function or the derivative is undefined at that value of x. So we have the cosine function starts at 1, the cosine of 0 on the unit circle. The cosine of 0 is 1. The cosine of pi over 2, remember, cosine is x over r. You should know that by now, but just to make sure. Cosine of 0 is 1. The cosine of pi over 2 is 0 over 1, so it's 0. Cosine of pi, 180 degrees, is negative 1. Cosine of 3 pi over 2, or 270 degrees, is back to 0. And then you go back to 0 radians, or 0 degrees, but we're going to prefer radians. You get to 1. So the cosine goes from 1 at 0, it goes to pi over 2. At pi over 2, you get a cosine value of 0. At pi, you get a cosine value of negative 1. 3 pi over 2, it's 0. And then you're back to 1 when you finish that full rotation, that first full period of cosine at 2 pi. Well, if you look at this white line, if I were to draw a tangent line at that point, that tangent line would have a slope of 0. So thus the derivative's value at 0, the derivative for the cosine of x, the slope at 0 is going to be 0. And then you start to draw tangent lines, and anywhere I can draw a tangent line, it's going to have a negative slope. And it'll get down to where the tangent line has a slope here of negative 1. So we start off with the slope of 0. The slope becomes negative, more and more negative, until it reaches a maximum or minimum slope value of negative 1. So this blue line starts at 0 and bottoms out at pi over 2. It bottoms out at negative 1. Well, then at past that point, later on we'll be learning this point right here called a inflection point, but that's beyond the scope of this lesson. The cosine graph is still falling, so the slope is still negative, but it's starting to cup upwards again. So it's still falling, but the slope is becoming less negative. So our derivative goes from a minimum value of negative 1 here, and the blue line, which is the derivative, is still below the x-axis, so it's still representing negative values or negative slopes. If I were to draw another tangent line here, it's still going to be falling to the right, but it's falling slower until finally here we reach the minimum of the cosine. I missed that a little bit. But at pi, the cosine value reaches its lowest value of negative 1, and so the cosine graph stops falling and starts to rise. So our derivative goes from being below the x-axis to being above the x-axis, because our slope stops falling. Our slopes of all of our tangent lines, or the curve, stops becoming negative and starts to rise up. So as you come up and you start to rise to the right, the slope of the cosine graph becomes positive, and our derivative function then is above the x-axis, representing all those positive slopes. So what we're seeing here in this blue line is a graph that starts at 0, falls to negative 1 at pi over 2, comes back up to 0 as the cosine stops falling and starts to rise. Those slopes become negative and then become positive. And then it goes up to a value of 1. That's here. The maximum slope for the cosine function without any kind of amplitude change is 1. And then it falls again and ends at, well, it doesn't end at 2 pi, it's these are circular functions, they repeat endlessly, but for the one period, we're stopping at 2 pi. So we have a negative sine function. Remember, the sine of x, y equals sine of x, the sine of 0 is 1, the sine of 0 is 0, the sine of pi over 2 is 1 on the unit circle, but our function fell to negative 1. And then the sine of pi, since it's y over r, is back to 0, and so on. So we have this blue line, which is y equals negative sine x. So thus the derivative with respect to x of the cosine of x is equal to negative sine x. I hope that, hope that didn't bore you and at least gives you some reason or some understanding of, well, at least where this equation came from. Let's apply these two rules or these two derivatives in 3 examples and, well, call this video done. For our first 2 examples, we have f of x is equal to 3 cosine of x. So the f prime of x, or the derivative of x, is going to be equal to, now this has a constant times our math function, our cosine of x. So we're going to use the constant rule, which says that to find the derivative of 3 cosine of x, that is going to be equal to 3 times the derivative with respect to x of the cosine of x. Well, that's 3. The derivative of the cosine of x is, as we just looked at, the negative sine of x. And so the derivative, or f prime of x, the derivative of x, is equal to negative 3. Whoops. Let's just write that so it's a little bit more legible. Negative 3 sine of x. Our second example, we have f of x is equal to 2 over x minus the sine of x. Well, this is 2 divided by x. And we have not learned the quotient rule yet, nor would I really want to use it for this, because it can be easily rewritten so that it's 2 times x to some power. And we can use the constant rule, which is very, very straightforward. And we have a subtraction, so we're going to use the difference rule as well and just be able to pretty easily find the derivative. So we're going to, before we start this problem, take this x to the first power, which is in the denominator, and rewrite this so it does not appear to be or does not use the division, and thus it's not a quotient or a fraction. We're going to float that x up and write 2 to the x to the negative 1. Normally we're trying to get rid of negative exponents, and if this were a final answer, say in an algebra class, I would prefer this to be 2 over x. But we are comfortable with getting rid of that negative exponent by moving the base either to the denominator of a fraction or vice versa. Here we have the positive fraction, so moving it up makes the exponent negative. Minus the sine of x. So the derivative of x, whoops, or f prime of x, I'm going to start saying derivative, is equal to 2 times the derivative with respect to x of x to the negative 1 power minus the derivative with respect to x of the sine of x. So this is going to become 2 times, we need to take that power, we're going to use the power rule, so we're going to take the negative 1 out front, have it negative 1x. Whenever you apply the power rule, we need to reduce our exponent by 1. So reducing negative 1 by 1 means, as always, subtract by 1. So negative 1 minus 1 is negative 2. And the derivative of sine of x is the cosine of x. So our final answer is 2, and I'm going to do 2 times negative 1 is negative 2. But I do want to write this so I have a positive exponent in my final answer. So I'm going to let x to the negative 2 fall to the denominator of this first term. And so we have negative 2 over x squared minus the cosine of x, which is our derivative of f. All right, so one more example, and I'll be done. Bye! So this example here isn't really much harder than my last one. I just have these x underneath a radical sign just to make sure that you remember how to go from radical form into fractional exponent form. Or rational exponent form. We don't really want to work with radicals. So this is going to become f of x is equal to 4 over x to the 1/2 power. This x has a power of 1. I have the index set at 2, so it's 4 over x to the 1/2 plus 2 cosine x. That is going to become, letting that base float up, so we have 4 times x to the negative 1/2 power plus 2 cosine of x. Now the derivative of f is going to be equal to, looking over here, 4 times the derivative with respect to x of x to the negative 1/2 power plus 2 times the derivative with respect to x of the cosine of x. This becomes 4 times, we're going to take that power, drop it out front, so negative 1/2 x. We're going to reduce that exponent by 1, and negative 1/2 minus 1, of course, we need common denominators, so we have 1 minus 2, which is negative 1 minus 2, which is negative 3 over 2, plus 2, and the derivative with respect to vector cosine is negative sine x. So we have 4 times negative 1/2 is negative 2. And I'm going to go ahead and allow this base with the negative exponent to float down at the same time. So we're going to have negative 2 from 4 times negative 1/2 over, taking this x and floating it down 3/2, minus, because positive 2 times negative 1 is minus 2, sine x. I'm Mr. True. Go do your homework.